Last episode, we faced an electrifying challenge just before departure, a mix-up with the new inverter. Our trusty old inverter had to keep things humming. But now the wait is over. We received our new Victron MultiPlus 2 inverter, and we're ready to supercharge our camper's power system. Will this be the upgrade we've been dreaming about? Or will new surprises pop up? Join us on this adventure to find out. Well, this is where we left you last episode. We got all the DC components built, and we were ready to move on to powering up the system on the AC side of things. That's when it all of a sudden dawned on us. We had the wrong inverter. There weren't enough places to plug in all of our wires. There was only room enough for 3 wires to be plugged in. You see, on our camper, it runs a split-phase system. What does that mean exactly? Well, first, the cord coming into the camper consists of 4 wires. There's a black wire. This is line 1 power wire in our camper. And then there's a red wire, and this is line 2 power wire in our camper. These wires, they split the power coming from the pedestal where you plug into the campground power.
So as not to get confused here, let's think of this in another way. You have one power cord coming into the camper. This is like a freeway with different lanes inside. You see this red and black wire? These are like 2 fast lanes, and each one is running 110 miles per hour, or volts in this case. You wouldn't want to reach out and touch a car that was traveling by you at 110 miles per hour. Danger. So be careful. These are your 2 hot wires. Now, instead of both of these wires getting off at the same exit and creating a 220 volt system, they each have a different destination with a different exit, thus creating 2 independent 110 volt systems. This is called a split phase system. This helps to balance the power demand needed in our campers to run all the creature comforts that we like to take with us, like our TVs, microwaves, heaters, hair dryers, refrigerators. These things are called loads because when you plug something in, it requires electrical power to operate. In essence, the term load refers to anything that demands electrical power from the system, causing that system to carry the load or providing that power. So that one circuit doesn't get overloaded while the other one is underused, these loads are split between the 2 systems to balance out the demand. Is this making a little more sense? Well, let's get back to and finish our freeway analogy. You also have this white wire, which is called the neutral wire. This is like oncoming traffic. This wire returns power back to the power source to complete the circuit. And finally, there's a green or a bare copper wire, known as the ground wire. This is like the emergency lane. If you were driving down the freeway and you experienced a problem with your car, you'd pull over to the side of the road. The ground wire acts in a similar fashion. It's a safety mechanism. In case of a fault or short circuit, it provides a path for the excess electrical current to safely return to the ground, preventing potential electrical shocks or fires. It doesn't carry power under normal operation, but it's crucial for ensuring the electrical system's safety.
Now guys, this is just an illustration to hopefully help you feel not so lost in the terminology. But be aware, these wire color codes are only for the AC side of things. DC power has its own color codes, and you need to know what you're dealing with before you touch anything. Because in a 12 volt system, the red wire is still a hot wire, but the black wire is a ground wire. You get this confused on a 120 volt system, you could be in for a shocking surprise. See what I did there? In a camper, you have 2 types of electrical systems. One for small appliances, like lights and chargers. These are your 12 volt DC system. And your 120 volt system, it runs your bigger luxury appliances as mentioned earlier. Now let's get some legal stuff out of the way and get on to our installation. This video is for documentation purposes only. It is not intended to serve as an instructional guide or primer on electrical systems or installations. The content presented here reflects our personal experience in installing our system and is not a substitute for professional advice, guidance, or instruction. Always consult with a licensed electrician or professional when dealing with electrical installations or repairs. Do not attempt any electrical work without proper knowledge, skills, and safety precautions. We assume no responsibility or liability for any injuries, damages, or losses that may occur from attempting to replicate any activities or procedures shown in this video.
So last episode, we left you after attaching these wire junction boxes to the wall. This is where all the AC wires will run from the supply to the inverter and then back to the breaker box. Because we opted to put all the electrical components in the front compartment, it required that I rerouted all the wiring. So this episode, I'll be connecting the conduit to the back side of these junction boxes and running the wires to their appropriate place.
All right, we're getting ready to run the power for the Victron system, and I've put these two couplers on the back side going through the box on the front there. And I'm just going to get those tightened up, get ready to run the wire and put it in conduit. All right, feeding that this way. And I just ran the first portion of this conduit, and I got the wire coming through it. Now I'm going to take another piece, going to measure it from here and run it back. You can see the end of it here. Can you see that hole up in there? That's where the wire is going to go back up through it and reattach it or reconnect to the fuse box. And the other one will go over to the side of the camper for the supply. But that's where I'm trying to get. Well, you see these cables, these are for the dump valve, so I don't want the wire obstructing that. So I'm going to run this just a little bit past it so that the wire comes through the conduit and it'll still be supported by that and not getting tangled up with the cables. So I've got to take this, come over here and mark where I want this to cut. Here's where it fits into it. So I'll mark that just a little bit, so right about in there. Alright, now I'm going to cut this piece right here. And now I gotta run this wire through this conduit. Alright, that's there, and you can see how it comes past these cables and gives it just a little bit. I'll support it up here as well, keep it off of that cable for sure, and that'll give me plenty of room and support to run this stuff and keep it away from the dump valve cables. That should be enough wire to go through the end of the conduit. Now let me go make sure I can bend this and start directing it to go through the hole in the floor, and then I'll come back here and feed it some more. Yep, you can see the wire already came out here, so I've got probably enough I can feed up through my hole right here. Alright, now let's go up top and see what it looks like. Yeah, we can see the wires already come out right there. Fantastic. Here's the main wiring harness. Comes in from the power. Your neutral comes down to the neutral bus bar. Your hot wire comes over here to this side of the 50 amp. And the red comes over to this other 50 amp right here. And then your ground comes down to the ground bus bar in the back right there. All right, now I've pulled the breaker box out of here. I've already taken the old wire loose and pulled it out. Now I've got the new wire coming in. So I just need to cut it, trim it up so that it fits in here just like the other one. So I'm going to kind of use this one to model this one after, how much wire and everything to cut. So that's what we're doing next. All right. I've gotten the red and the black and the ground. I've got this red and this black and this ground installed now. All I have left is get this white one in here. It goes on the bus bar right here. There.
All right, we got the breaker box all wired up. Now I'm just going to go ahead and screw that back together, put it back in place, and then I'll go out to the front. I'll wire that up to the Victron. Then all I'll have to do is hook up the supply and run that, and it'll all be hooked up. After I put the breaker box back together, I pulled the old wire out and I ran the new wire through the conduit to the inverter, as I had done before. I then made all our connections at the Victron MultiPlus 2, then reconnected the power plug on the side of the camper so we could plug into the shore power. This shows green, white, red, and black. So the ground is always green. Black is load 1. Back in the old hole.
And does it matter if you put them all in upside down?
I did not. That was a good one.
Made you think.
Yeah, you did. You got me. Fancy'd be proud. Doesn't detect any faults there.
We got it all wired and it's operational, but we're not finished. Now we have to go in and program the system. The inverter can handle lithium batteries easily, and it's made for it. But it can also handle AGM batteries, that's those gel-filled batteries. But it comes pre-programmed for lead acid batteries, and they have a completely different charging profile. So we have to go in and change the charge parameters, and of course that requires an additional part. I had to purchase a data cable and an interface cable that I could plug into my computer to communicate with. So stay tuned for the final episode to see what we have to do to get that taken care of. Hey, if you're finding this series helpful, I'd appreciate if you could leave us a comment in the comment section below. And if you haven't already, check out the other videos in this series. I'll leave the links at the end of this video. Well, that's going to do it for this week's episode. If you're new here, make sure you subscribe to the channel. Don't forget to give us a thumbs up and ring that bell so you don't miss a single episode. Till next time, guys, stay safe out there.